Morning, everyone. Okay, so the other day we talked about speed mainly. We did the distance time graphs, and then we discussed how you get a speed from a distance time graph, which essentially is you find the slope of the graph. And we did some rise over run calculations. So I gave you this to do. Graph is a little bit blurry, I don't know why. Well, hopefully you were able to read it. Okay, so a dog runs in a straight line down a road. Its distance from a signpost on the road is measured. So this is the dog down here at the signpost. And then after 1 second, that dog is 5 meters from the signpost. After 2 seconds, that dog is 10 meters. After 3, the dog is 15 meters away from the signpost, and so on. Describe the motion of the dog. Now, up here, where did I write it? Yep. A sloped straight line means a constant speed. So we discussed this. So that's what they're getting at here, okay? We have a sloped straight line. So we can describe this dog as moving with constant speed. Okay. When was the dog 20 meters from the signpost? Okay, so when is a measure of time. So 20 meters, the distance is here. Here's 20. So if I go across, hit the line, drop down, 4 seconds. Okay, the dog was at 20 meters from the signpost at 4 seconds. What was the distance of the dog from the post after 4.5 seconds? Okay, so now we're in between 4 and 5. No, I'll just do it like this. So there's 4.5 seconds. I'm going to go up till I hit my graph. I'm going to go across. And I'm absolutely in between 20 and 25. So what's that, 22 and a half? So 22.5 meters. Okay, find the slope of the graph. Now, we didn't do this the other day because, obviously we did slope, but we didn't do this because we had a very clear, the graph the other day was like this. So there was a very clear start and end point when you were doing the slope. You can, when you're doing the slope, you can use the entire line or you can use part of the line. That's up to you, okay? We did this when we were doing patterns in maths. And you can choose like a point near the start of the line and a point near the end of the line and create your triangle, or you can just do the whole line. Okay, it doesn't matter, especially for a line like this. It's not going to matter because it's the same. Okay, so I'm going to pick this point here and I'll pick this point here. Okay, so there's my 2 points. And then I make my triangle. So I go down from this one, stop there. Oh. And then I'm going to go across from here, stop there. Okay, so the rise, which is the up and down, starts here. Remember, for the rise, you're looking at the y-axis. So it starts at 5 and it ends here at 25. So that's a rise of 20. The run then is horizontal, so we're looking down here. So it starts at 1 and it ends at 5. It's 5. So that's a run of 4. So then to get the slope, I'm just going to bring this down a little bit because I have no room. So to get the slope, we do the rise over the run. The rise is 20, the run is 4, and that's a slope of 5. Okay? And it doesn't matter which points you choose. You would get a different rise and a different run. So this part would be different, but your answer should be the same. Okay, so regardless of whether you took the entire line, or like I did part of the line, or even if you took part of the line but you took a different part to me, you should still end up with 5. Okay, so that is the slope of the graph, which is what we were asked. And what is the speed of the dog? Okay, so remember I told you the other day, and I explained all the logic of it, that the slope is the speed. So if the slope is 5, then the speed is 5. But because it's a speed now, you have to put a unit on it. So it's a speed, so the unit is meters per second. Okay, so they are all your answers. So please correct your work and let me know if there's any issues with them. And we will keep going. Okay, so the next part is changing speeds. Okay, so far we've talked about speed, distance, time. We spoke about the vectors, which were velocity, displacement, time, and I told you the difference between the two. And we discussed distance time graphs. Okay, so when you're doing that relationship, that speed, distance, time relationship, essentially what's happening is that over a given time, the distance changes. So let's say I get one of you up there in the lab and I ask you to stand at the back of the room and walk, health and safety, walk from the back of the room to the front of the room, and I'm going to time you. Your distance from the presses at the back of the room is changing as my stopwatch is moving forward. And as a result, you are moving at a speed. Okay, so speed is a changing distance with respect to time. Okay, so as time changes, distance changes. We're now moving on to as time changes, speed changes. Okay, and that moves us into the world of acceleration. Okay, so we're going to talk about what acceleration means, and it has a slightly different meaning in physics than in, not wildly different, but I'll explain what I'm talking about now. Slightly different meaning in physics than in your normal language. I'm going to measure and calculate accelerations. Acceleration is not a measured quantity, it is a calculated quantity. So you will not measure acceleration, you will measure different things and as a result get acceleration. And predict the motion of objects experiencing. Why are they doing this plural thing? I don't like that. Anyway, right, so let's have a look. So acceleration, if I asked you now what's meant by acceleration, I think you'd all tell me that it's a car stopped at traffic lights, hitting the, and there's the word, the accelerator, and the car speeds up. When you talk about like high performance cars and things like that, they always tell you about, it does 0 to 60 in 10 seconds, 5 seconds, 4 seconds, and that's kind of a measure of the power of the car, how quickly it can get up to a high speed. So I'm pretty sure that's what you would tell me. In physics, here it is here actually, acceleration is speed changing over time. Now, just to note, It's speed changing over time. So any change in speed is an acceleration, which means if you are sitting at a traffic lights and you speed up, so you're going at 0 meters per second and you speed up to 30 meters per second, and that takes, I don't know, 4 seconds. It's my car. So my car is sitting here at the traffic lights, and then I'm sitting in my car and I hit the accelerator and I speed up to 30 meters per second and it takes 4 seconds. I have accelerated. I think you would all agree with me. Now, if I'm back here in my car, my car has changed drastically. But if I'm back here in my car and I'm traveling along happily at, I don't know, 60 kilometers per hour, and I see the traffic lights and the traffic lights go red, and I hit the brakes and I go from here to stopped in time for the traffic lights, has my speed changed? Yes, it has. I've gone from travelling at 60 kilometers per hour to travelling at no kilometers per hour. So my speed has changed, which means this is also an acceleration. Okay, so it's just, acceleration in physics is just a changing speed. It doesn't matter whether the speed is going up or the speed is going down. Both of them are referred to as acceleration. Okay, technically speaking. Now, they do use the word deceleration. Definitely not two L's in that. Okay, so the word, what's wrong? Anyway, the word deceleration is used, but it technically doesn't need to be. Okay, acceleration is a changing speed with respect to time. It doesn't matter whether that speed is changing up or that speed is changing down. Okay, and here's the formula. Acceleration is the change in speed over the time taken for that change. Okay, so again, it doesn't matter whether it's up or down. The top line is a change in speed or a difference in speed, so that will always be a subtraction. You're always going to subtract two speeds from each other. And then the bottom line is just how long did it take to get from the first speed to the second speed. Okay? The unit for acceleration. Okay, so as I said, acceleration is it's one of those derived quantities. It comes from a couple of different things. So you can see here, the unit for speed on the top is meters per second, and the bottom is seconds. So remember I said that this is just a sideways version of a fraction. Yeah, so it's meters per second. So essentially what we have is meters. Can you see where my cursor is? Meters per second per second. And the way we write that is meters per second squared. Okay, we have 2 seconds, so that becomes seconds squared. So the unit for acceleration is meters per second squared. Okay. All right, we have a little example here. If the speed of a car changes from 15 meters per second to 25 meters per second in 4 seconds, then the acceleration of the car can be calculated as, okay, so obviously it's an example in the book that they do, so I'm going to show you how to do this, okay? So if we're trying to get acceleration, what we do is we do the final speed minus the initial speed or the starting speed. It doesn't really matter how you say that, okay? So that's this bit. That's the change in speed bit. Excuse me. We do the final speed minus the initial speed. And then on the bottom line, we have time. Okay? So it started at 15, so it ended up at 25. So 25 is the final speed, minus the initial speed was 15 over, how long did it take? Oh, in 4 seconds. So 25 minus 15 is 10 over 4. And that is 2.5, and your units are meters per second squared. Okay, so that's how you do the calculation. You subtract the speeds and divide it by the time. Okay, just a little mention that acceleration is a vector. Okay, remember that a vector means it has both magnitude and direction. Okay, so in a question like this, where they gave it in terms of the speed of the car, speed, if you remember, is a scalar, which means it has no direction. So in the question, I was given no direction, which means in my answer, I can't give it. You can't invent a direction. I can't, even though acceleration is a vector quantity and it should have a direction, I can't give a direction because I wasn't given one in the question. Okay, but they may use velocity as opposed to speed, and velocity is a vector and would have a direction. And if there is a direction mentioned in the question, then you should put a direction in your answer because acceleration is a vector. Is that okay? So in the example, there was no direction, so I couldn't put a direction on it. But there, in an acceleration question, there may well be a direction. And if there is, please make sure you add it because acceleration should have a direction because it's a vector. Okay, so there's 3 questions there. Not as blurry as the last one, thankfully. So give them a go, and I will be back on Monday, which means I will be there to mark these in class on Tuesday. Okay, so have a nice weekend, and hopefully you get on okay with them.